This is R.D. Sharma Solution Class 12th. Chapter 19, we are taking exercise 19.31 of indefinite integrals. As we have done 3 questions now, we are quite aware how to do this. So if you take x square equals to t, then it will be difficult to solve this. Well, it is solvable, but what to do with this x square differentiation and all that stuff. So let's make it easier. Multiply 2 numerator denominator. What is the benefit? The numerator is 2. You can write it as 1 plus 1. Now you already have this. You have to do something with x square, right? So we'll add a x square and subtract a x square. That is 1 and 1 is 2, and we are adding and subtracting x square. So how to write this? If you take x square plus 1 minus x square minus 1, just try to open this. You will get back 2 again. That's why I'm showing this. So we can write this 2 as x square plus 1 and x square minus 1 with a negative sign in between. Half we are going to do a deal later. So we have the x square plus 1 as the first term, x square minus 1 as the second term. That is, you already understand that in the denominator you already have x raised 4 plus x square plus 1. Now I am having 2 different terms with this denominator. Same denominator. X raised 4 plus x square plus 1. Now this question needs to be understood very well, because these 2 parts which I am showing you, these 2 different parts, are actual questions which are going to come again in this exercise. So in both the terms you have to divide by x square. So I am taking I1 separately, I2 separately, but in front of you I am going to solve both of them together. So this x square plus 1 divided by x raised 4 plus x square plus 1. I2 becomes x square minus 1 divided by x to the power 4 plus x square plus 1. Divide numerator and denominator by x square. When you do this, all of them, right? I1 and I2 both. When you do this, you will get something which is related to the previous questions. How? In the numerator of the I1, you will get 1 plus 1 by x square. In the denominator, the same thing will come, because denominator is same for both the cases. Numerator in first case is 1 plus 1 by x square. In the other case, that is I2, you get 1 minus 1 by x square. So I'm dividing x square everywhere. X square plus 1 by x square plus 1 will remain in the denominator. But we ought to get 1 plus 1 by x square in the numerator for the first case. So we'll take x minus 1 by x equals to t. Why we are taking it, you already know now. Similarly, we need 1 minus 1 by x square in the numerator for the second case. For that, not second case, actually it is the second term. For that, x plus 1 by x equals to t. Now differentiate both of them. dt by dx will give you 1 minus, 1 plus 1 by x square. Here you will get dt by dx equals to 1 minus 1 by x square. So we are getting the numerator from the denominator, which is different in both the cases. Now if we are integrating these two, actually we are integrating it. So I1 has 1 plus 1 by x square into dx, and this we are getting as dt. If we put x minus 1 by x equals to t. In I2, we are getting 1 minus 1 by x square dx when we put x plus 1 by x equals to t. Now when you square this x minus 1 by x whole square, it will be x square plus 1 by x square minus 2. We already have a 1. So if you add a 2 and subtract a 2, that will remain the same. But you can take this x square plus 1 by x square minus 2 as x minus 1 by x whole square. In the second case, if you put x plus 1 by x whole square, if you try to find out the value, it will be x square plus 1 by x square plus 2. Just add a 2 and subtract a 2. Don't worry about any other thing. Now x square plus 1 by x square plus 2 will form x plus 1 by x whole square. This will be the denominator. But you already have a negative 2. So 1 minus 2 will be negative 1. In the first case, it will be x minus 1 by whole square. We have utilized x square, 1 by x square and negative 2. So 1 plus 2 will be 3. Now this I am going to write as root 3 square. This I am going to write as 1 square, because 1 square, there is no point in writing under root 1 whole square. So I1 has now become 1 plus, let me write the direct value now. It's dt divided by, it was x minus 1 by x whole square plus root 3 whole square. The second one, I2, again dt was the numerator and denominator was x plus 1 by x whole square. I'm just making you recall all these, minus 1 square. We have taken it as t. So you can write t square plus root 3 whole square, integration of this. In the second part, it's t minus 1 whole square, or t square minus 1 square you can write. This 1 by x square plus a square formula you will use integration. So it will be 1 by a tan inverse x by a t by root 3. In the second part, it's x by x square minus a square. It will be 1 by 2a log, a is 1 here. So I am writing this 1 by 2. Log t minus 1 divided by t plus 1. Now these are in terms of t, and half was already there. I told you we multiplied numerator and denominator by 2. So I've just introduced half in both the terms. But now we have to replace t also. In the first part, we have taken x minus 1 by x as t. It's taking the tan inverse inside term, and here also taking the inside term of log. So we took x plus 1 by x as t, so t minus 1, t plus 1 will form like this. So the left part will become x square minus 1 by x into root 3, which is inside tan inverse. And what is inside log? It will be x square plus 1 by x minus 1. Denominator will be x square plus 1 minus x. So x square plus 1 minus x divided by x, and x square plus x plus 1 divided by x. We can cancel these x. So we'll put it here, and we'll put x square minus 1 divided by x root 3 inside tan inverse. So now I am doing I1 minus I2, which is our final result. So 1 by twice of root 3 tan inverse x square minus 1 divided by x root 3 minus 1 by 4 log. So when we place t as x plus 1 by x, we got log x square minus x plus 1 and x square plus x plus 1 plus a constant of integration. That's your final result. So this is how you're going to go about it. It's a different kind of way which the solution has been shown. X square minus 3x plus 1 divided by x raised 4 plus x square plus 1. Now we know that x square plus 1 or x square minus 1 in the numerator will make our life easier. There is one more thing, negative 3x, which is there. So we'll separate this term or divide this term into two parts. First, we'll take this x square plus 1. Denominator remain the same. It will not change for both the terms. So I'm following the divide and conquer approach. This x square plus 1 divided by x raised 4 plus x square plus 1 was just being done. I told you how to do this. That's why I indicated that this is going to come again and again in the later questions. The second part is 3x divided by x raised 4 plus x square plus 1. So we are going to integrate it as I1 and I2. Now I1 we have just done. So let me write the final answer here. So you have to put x minus 1 by x as t, divide numerator denominator by x square, you will get 1 plus 1 by x square, x minus 1 by x. If differentiated, it will give you 1 plus 1 by x square, and that's how it will be done. In the previous question, we multiplied numerator denominator by 2, but here there is no point of 2, no question about 2. So we'll write this except to the previous question, first part. 1 by root 3 tan inverse x square minus 1 divided by root 3x. This is clear now. I am just writing the direct result of the first term, which we already completed. Now the second part needs some attention. We just assume that 3 is outside. We'll deal it with later because constant term, because it's not going to add anything to the solution. So we'll just take this 3 out. We are left with integration of x divided by x to the power 4 plus x square plus 1. Now you can place x square equals to t. dt by dx will give you 2x. That means in order to get this x dx, it can be replaced by dt by 2. X dx is already there. Whenever I write this integration, I tell you that dx is already there. If I forget, you have to understand that. Now this dt by 2 in place of x dx, where we are writing 3 is already there. Or you can write it here also, 3 by 2. But anyways, x square is t, so x raised 4 will be t square plus t plus 1. Now I told you earlier that it is difficult to solve this, but we will make it as a perfect square. It's easy. We will make it as a perfect square and apply the formula whichever is applicable here. So we have t square plus t plus 1. What is the coefficient? 1 divided by 2 whole square. Add it, subtract. So 1 by 2 whole square or negative 1 by 2 whole square. So a square plus b square plus 2ab t square plus 1 by 2 whole square plus t will form t plus 1 by 2 whole square. 1 minus 1 by 2 whole square, that is 1 minus 1 by 4, which is 3 by 4. And in order to make it as a perfect square, we can write it as root 3 by 2 whole square. So plus root 3 by 2 whole square you can write. So we can write this as, I'm just including 3 now, 3 by 2 integration of dt divided by t plus half whole square plus root 3 by 2 whole square. Now what is the formula we can apply? Dx divided by x square plus a square integration. It's 1 by a tan inverse x by a, that is already known to you. Let me write it. Integration of 1 by x square plus a square is 1 by a tan inverse x by a. In this case, a will be taken as root 3 by 2 and x will be taken as t plus half. So 1 by root 3 by 2 tan inverse t plus half divided by root 3 by 2. Let's resolve it. Let me resolve it here only. 3 by 2, this root 3 by 2 in the denominator will go up and form 2 by root 3. 2 gets cancelled. You can multiply root 3 in the numerator denominator. 3 will come in the denominator. You can cancel this. Root 3 will come. Now t plus half by root 3 by 2. Let's solve this also. This will give you 2t plus 1 by 2. And then root 3 by 2 gets cancelled. You get 2t plus 1 by root 3. Please remember that t was taken as x square. So in the next step, I'm going to replace t by x square and write the direct answer. So t will be replaced by x square just now. So I has become, the first term was already, by default, you have known in the previous question. So I'm writing directly 1 by root 3 tan inverse x square minus 1 by root 3x. The second term has come as negative root 3 tan inverse 2t. So t will be x squared. 2x square plus 1 divided by root 3, and let's close it and plus a constant of integration. This is your final result. Now this is the result, or this is the solution. You can refer x square plus 1 divided by x raised 4 minus x square plus 1. Now I can vouch that you are aware of how to solve this because of the previous 5 questions we have already done. It's very straightforward. Divide numerator denominator by x square. Use this x minus 1 by x as t. You'll get the numerator 1 plus 1 by x square, and use this x square minus a square integration in the division. Now x square minus 1 divided by x raised 4 plus 1. First thing is divide numerator denominator by x square. What do you get? 1 minus 1 by x square in the numerator. Denominator will give you x square plus 1 by x square. This is integration, what we are doing after division by x square in numerator and denominator. We need 1 minus 1 by x square in the numerator, so after differentiation, so you have to take x plus 1 by x in the denominator. X plus 1 by x whole square is this one. Now just add a 2 and subtract a 2. Now you can take first 3 terms of the denominator and you can call it as x plus 1 by x whole square. These 3 terms will form x plus 1 by x whole square. This is negative 2, so you can make it as a perfect square with minus root 2 whole square. Numerator is what? If you take x plus 1 by x as t, it will give you dt by dx as what? 1 minus 1 by x square. Dx can be taken on the right. This whole 1 minus 1 by x square into dx has become dt. This x plus 1 by x, you can write it as t. So the actual thing after taking t as x plus 1 by x has become like this. Dt divided by t square minus root 2 whole square. Now this solution is, the formula will be 1 by 2 8, a is root 2 here, log x minus a, which is t minus root 2 by t plus root 2. And this comes in the modulus sign plus constant of integration. T we can replace by x plus 1 by x. Let me replace it here also. X plus 1 by x minus root 2 and x plus 1 by x plus root 2. This will give you, this will be x square minus root 2x plus 1 divided by x square plus root 2x plus 1. Now we can replace this and we'll write the final answer. So the integration has become like this: 1 by 2 root 2 log modulus of x square minus root 2x plus 1 divided by x square plus root 2x plus 1 plus constant of integration. This is your final result. So this is actually the second part of the previous question we have already done. Alright, this is the previous question part, because I told you I1 and I2 I took x square minus 1 and x square plus 1, if you remember. So it's kind of same thing. Alright, this will take in the later discussion. Till then, thank you so much. Have a good one.